Moving on to the solar system. The solar system was formed about 4.6 billion years ago from a vast cloud of gas and dust. It comprises the sun, 8 planets with moons, an asteroid belt, and celestial bodies such as comets. So there are two sections of the solar system, and it is inner planets and outer planets. Inner planets consists of Mercury, Venus, Earth, and Mars, which are the 4 closest planets to the sun, and they are referred to as the inner planets. So the characteristics of the inner planets are thin atmospheres, solid surfaces, few or no moons, and no rings. On the other hand, outer planets consists of Jupiter, Saturn, Uranus, and Neptune, which are the 4 furthest planets from the sun, and they are known as the outer planets. The characteristics of outer planets are thick atmospheres, lack of solid surfaces, many rings, and many moons. The asteroid belt is the region that separates the inner and outer planets. It consists of numerous rocky bodies called asteroids. Hence, it is called the asteroid belt. Comets. Comets are dusty, icy bodies that orbit the sun beyond Neptune. Both comets and asteroids are much smaller than planets. So as you can see from this diagram here, there's Mercury, Venus, Earth, and Mars, and this, since it is the 4 closest planets to the sun, they are inner planets, and the asteroid belt here separates the inner from the outer planets, and the outer planets here shows Jupiter, Saturn, Uranus, and Neptune. Shifting from solar systems and space, we're going to now focus on more of the properties on Earth. So we will be moving on to seasons. So Earth's tilted axis and seasons. So Earth's axis is tilted, which causes different parts of the planet to either face or move away from the sun as Earth orbits it. This axial tilt is responsible for the seasons changing. So to be more specific, summer and winter hemispheres. When the northern or southern hemisphere points towards the sun, it's summer in that hemisphere. And during this period, the sun's rays are more direct, leading to warmer temperatures. And on the other hand, when the northern or southern hemisphere points away from the sun, it would be winter in that hemisphere. The sun's rays are less direct, resulting in cooler temperatures. Opposite seasons in the hemisphere. The northern and southern hemispheres experience opposite seasons due to their different orientations relative to the sun. Equator and poles. Throughout the year, the equator receives the most direct sunlight, leading to warmer conditions. And in contrast, the poles receive the least direct sunlight, resulting in colder temperatures. So moving on to global winds and currents. Currents are steady flows of fluids, such as air or water, within a larger body of the same fluid. Prevailing winds are air currents that primarily blow in a single direction. And these global wind patterns are influenced by Earth's uneven surface heating. Moving on to Coriolis effect. As prevailing winds cross the ocean, they generate surface currents in the water, and both wind and surface currents appear to the curve due to the Earth's rotation, known as the Coriolis effect. Surface currents and gyres. Surface currents interact to create large rotating systems, which are called gyres. Gyres facilitate the movement of heat from the equator to the poles, which helps to regulate temperatures on Earth. Deep currents and density. Deep ocean currents are driven by differences in water density, and denser, colder, and saltier water sinks, while less dense, warmer, and less salty water rises. Overturning circulation. Horizontal and vertical currents combine to form the ocean's overturning circulation, and this interconnected system circulates water and heat throughout global oceans.